Okay, it's recording. Right. So we're recording now. Okay, so I was saying we're just going to like abstract the whole simulation layer away, the simulation and the hardware and everything. And we'll just do just Python. Okay. So I will open this in VS Code. This is like standard procedure. If you want to open a folder in VS Code, just code full stop, and then it opens a folder in VS Code. I don't just open VS Code. I make sure like I open a folder. I think that's something I can start with. So you can see, okay, let me make this bigger. I think this is big enough. You can see the VS Code comes up here with, you can see this other Python recap. So if you were to, let's say we have this folder. So I do code full stop. It opens another VS Code, and you would notice this VS Code is the file name, or rather the folder name, our robotics call 1. This one is the Python recap. And also you would notice that you can see that we have Python recap here. And then you see here it's just this one. I want to work only on Python recap folder. I don't want all this noise. That's why I'm just opening this, right? And if I say, oh, okay, let me create a file here, 1.py. It shows here. So that's why I think this is intuitive. This is the folder. Anything you create is going to reflect in the other VS Code. So if I create another file to the py, it also shows up here. There are two different VS Codes, but this folder is open separately in another VS Code. So it's something you might want to understand, because VS Codes can be, if you don't understand it properly, you can end up in a bit of a mess. So this is what I want to work with now, right? Okay. So it's literally the same thing on a Windows PC. It's the same thing. VS Code is extremely like similar cross platform. The only thing that changes most times is how you execute C++. Python found a way to like make sure everything looks completely identical. I'm trying to get my charger. Okay. Okay. My screen is not showing. Are you okay? I'm going to cry. My screen is not showing, serious. My screen was not showing when I was doing that example of the VS Code and everything.
I can't see.
Ah, okay. I want to switch to, I mean, not necessarily switch, but I just want to have my Windows PC on just in case we need to. Windows ejecting is there. Mm. All right, this is up finally. Mm, Okay, so just in case we need Windows. All right, I have VS Code running. I can resize it. Close. Let's take this on this side. Let's collapse that. All right, so someone's trying to call. All right, so we're going to start with basics of program. Usually, when you start learning anything, I think the first thing you learn is print hello world. So basically, print is like to display something on the terminal, and then we have print hello world. I can still say, okay, print. This is a sample Python script, and then you run it. It shows you hello world. This is a sample Python script. So nothing too special about this. I can also um, name equal to input. What is your name? So what happens here is your name is a variable, and input is saying it wants to take in your name. So it's going to print hello world. Now this is like procedural programming. It runs from the top to the bottom. You start with print hello world. It prints, this is a sample Python script, and then this is to take in name. It takes in the input. Right? If I run it out, I'll just show you. So here we see it prints hello world. That's the first line, line number 1. This is the sample Python script, which is the second line. And then it's asking us to enter our name. So if you notice, it hasn't gone to this 6th line yet, because it's still waiting for an input from us. So basically you can be like, oh, okay, yeah, my name is Bakel. And then it's like hello Bakel. So this is one of the first things you learn when writing any program at all. In something like this, you learn, or you've learned something, which is you learn how to assign variables. That's what a variable is. Name is a variable. A variable is like it's like a container that holds data. It's like, yeah, basically that's what it is. The container that holds data. So you can have numbers as variables, so many things, whatever as variables. Yeah. So if you notice, I have like recommendations, suggestions. All this is set up here. If you watched YouTube videos on how to set up your Visual Studio Code or your VS Code, you can search here and then you can search for Python, and then you see a lot of features. This now, sorry, my screen is too big, so it's cramping up the text. So this now is one of the extensions that you can use for Python. I think it comes with autocomplete and a ton of other things. Basically, this is something you would go over. I have a few of them installed. I have the one for Microsoft. Basically, all that I have installed is for Microsoft because I don't really trust any other like producer of Python stuff. So I just have the ones installed for Python extension, Python debugger, and Pylons. So all these are things you can always read, right? But we are dealing with this code. Let me increase it again in case it's too small. So here, if you noticed, we've gone to age, which is another variable. We want to request for age. You can see this inputs is the same as this inputs here. Like something changed, we've added integer to it because what we're expecting is a number. So it converts whatever you put into a number so it can print it here. I'm just running over all these things like on a higher level because if you can notice, there is this bracket with a name, there is brackets with an age. This is where your variables would be substituted. So anywhere we have an age, which is the variable, the Python script just puts it there. Right? So running something like this, it's going to ask for our name first. Then we have our name back here. And then it asks for our age. And I'm like, oh yeah, okay, I'm 103. And it says you are 103 years old. Yeah. Something we can also do is to put our name and then tell them I am 2 years old and watch the program crash. That's because it tries.
Sorry, I didn't raise my hand though.
Yeah.
Please, why is there F at the back of that string? Print.
Yeah. Good. So in I think this was introduced in like Python 3 or so. It was not always there, but we want to, this F allows us to do this. Usually, I mean, in the good old days when we're using Python 2, what we do is we concatenate. We do something like this. We do UR, and then we come outside. We do plus, and then we string. I don't know if you're familiar with the whole process. This is what we do back then. And then what happens now is you turn the age, which was initially an integer, into a string first. You can see there is no F in this case. I'll come, let me run it just to show you. It gives you the same thing. I tell you my name is Bakel. I tell you I'm 103. And it's the same thing, right? This is the old way of doing it. This is the one most people are conversant with. And then this is the new one. And the reason why it's like is because it's simply faster, right? Imagine having to string everything because I want to like convert it. It's really slow. And then with numbers, I would show you something. With numbers, you can now easily approximate, because like if we wanted to approximate on earlier Python, and I used Python 2.7 a lot. If you want to approximate there, you would have to, I think it was there's a math library for that, and then it was a bit messy. But with F, once you just declare this F, you can do a whole lot of things in your strings. So that's the idea. So now basically these are like the kind of questions that I also expect, because I know you can only ask the kind of question when you have prior knowledge. But either ways, whatever you see on the code, feel free to always ask, because I have no, I'm just like teaching you guys what I have in my head and what I feel you would need. It's not like there's a script or something. So these are variables. There are things that we call data type. Yeah, everybody must have heard of data types. There's string. Um, okay, so I'm using autocomplete a lot because why not? Um, a string is like words. It's like a word. Let's put it like that. That's the best definition that we can get. Although a more technical definition would be it's a series of characters, or char, the same thing. A fun fact: there are no strings on C or C++. Like string is not like a natural thing on C or C++. You have to like either make it from a series of characters, or you have to import a library for strings. It's not like a natural data type. But here it is like a natural data type for Python. So there's some functions that are in Python that does like a couple of things for us. Of course, we know what print is. Print greeting is going to tell us hello. There's a function called type, function, method, class. What it does is it tells you what is the data type of this of whatever you put in it. We'll come to that shortly. And then there's length. This just tells you, oh, what's the size, the length of the string. So if we are to predict, this would print hello world. This would print string, and this will print 5. So what I'm going to do is let me move this into another code so like it's not messy. And I think I can name this. So in case you want to like go over it again, I can name this as data type. There is data type, and I don't know if you're ahead of data structure. Those are like two different things. Data type and data structure. I'll just start this intro. I'll name this intro. We name this to intro. Okay. So on the data type, remember what we said? It shows us hello. Now it shows us the type, class, string, str, and then 5. That's the length. So what would that data type do I have off my head? Okay, there's integers, and there's age. You print age. You have the type. Now you cannot do length of an integer. Like the integer is 25. It doesn't make sense to do length of an integer. But like length of a string is like how many letters. Are you going to ask how many numbers are in 25? I mean, it doesn't even like make sense. The equation doesn't really make sense. So let's work with this. So we have integers, 25. Again, print, and then the type, and like one random mathematical operation. Right? If you notice, we're not putting F again. Why? We're not putting F because the reason why we put F is we want to put variables and normal words together. So if we're to put F here, it's going to be a waste. It's going to be a waste because it's just longer characters. It's going to be F hyphen age plus 5, and I would now close the brackets. Like it's just unnecessarily lengthy when we do not need it. Spanish keyboard, typical. Okay. Yeah. So this is what it's going to look like. But like, isn't this just too much stress for, I mean, something that is not necessary? Except you want to put like a word in it and you are like, um, my age plus 5 is, then that's when it becomes worth it. Else, just go ahead and print the age directly, right? So I can run this now, and then we see 25. We see our data type is integer, and then we see my age plus 5 is 30, right? So 103. So good. That is how we proceed. What else? What else? There are different data types too. There are data types that are, you can also make your data type actually by creating a class, but let's leave that for another like stuff. Now we have floats. What floats do is like decimals, but like longer decimals, because there's floats, there's doubles, right? These are more complicated stuff. Oh, there's Boolean. No, I'm looking for doubles. Da, 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 da. Yeah, I'll just define it myself. Double. 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 Yeah, great. Now, the difference between floats and doubles are precisions. How much can you represent? Floats are usually more precise because they can take in more more decimal points and things like that. Something you should bear in mind is each time you do something like this, you take out your RAM. Like, it's not like you can define infinite amounts of variables. I think that's how in one class I was explaining how I always try to like reduce the number of variables I define, because the truth is you don't have an infinite amount of memory. With each time you specify this, it tells you, okay, you are actually taking some bytes. If I fully remember, it's usually like 8 bytes for double, 4 bytes for integer, yeah, something like that. So, and then that's like what happens underneath. But let's not like dive into all of that. So basically, what we are doing now is floats. You see 5.9. You can see the height. It prints it. It tells you what type it is, and then like a little bit of an addition. Right, good. The thing is, you cannot do an integer to be 10.1. Running this, where is my integer? You can see running this typical Python, it shows us 10.1. It automatically like converts it because there is no type checking. That's another thing we also need to look at. We would use it in ROS. Type checking is when they are like, I said, okay, we're talking about integers in C or C++. Let me switch to a C++ code real quick so you see what I mean by type checking. I think it'd be good to like have contrasts. Just come here. Let me do it this way. Give me a C++ code. Give me C++ code. Anyone will do. Okay, that didn't work as expected. Copy from here. Paste in Python. So, okay, so we have a C++ code here, and what you will quickly see is how irritating it becomes. This is a variable theta1 equal to 30, right? but we must always put what data type? Integer. Whereas if we come over to Python, we are free to just declare whatever we want. No need to put integer behind it. No need to put anything behind it. So in the most recent Python, I think it was PEP. They did some kind PEP 37, 38. I can't remember, but they did this kind of like type checking um thing where you like import a you can import a library for type checking, but that's like that's far ahead. You can read things like that. So there's Boolean. A lot of us know what Boolean is, true or false. I don't know if you heard of truth table too. Either ways, Boolean is like only two data types that exist for Boolean. It's either true or it's false. And then you can do a couple of things with Boolean. You can use not, you can use and, you can do this whole truth table or logic gates kind of thing. That's just how Booleans work. You can build all gates and gates. Again, we're not going into that because that does not directly concern the training. So what next? What next? Am I supposed to um hello world, data type? Okay, flow. When I'm in flow, how does the program how does the program move? How does the code move? When we talk of flow, we talk of if else, we talk of for, we talk of a whole lot of different things. Um, let's say flow.py. Okay. So let's okay. So now, if you notice, right, if you're writing like larger codes and like I don't think anybody just sits down and type out the whole code base, right? No, it doesn't work like that actually. You might want to use like a boilerplate, a template, I mean you could type everything from scratch, it's fine. But most time there's already an existing code base that you just use and you adapt to. But the point is if you don't know what the code is doing, you cannot use all those things. And again, it's not like I know I throw a lot of shades at AI. I know I you need to see my status when I'm insulting AI. But the truth is, they are pretty good at coding to some extent. So if you tell ChatGPT to give you code for a for loop or something, it's most likely going to be accurate. So if you can, yeah, you can do all of those. But for every code you outsource, be sure you understand how it works, because by the time you have like 1,000 lines plus and then AI can't keep up, you'll be forced to look at the code yourself and like it's not like it's going to like work forever for you or that kind of thing. And yes, maybe there's going to come to a time when it can do all of that, definitely. But till then, why put yourself in technical debt till then? So for the flow, we can use this example. Let's there's a culture there's a culture here for tipping. Yeah, when you so you can already see that they're giving me suggestion for a pseudocode, but I don't think I want that. I don't want that suggestion. I want to use things that we already know. So let me do. So like tipping is like what I have in mind is if who wants to join? Okay. Output and visualization. Victory, you said output and visualization. What are outputs and what are visualizing? Victory. Okay. I can't.
Yeah,
Yeah, what
yes.
are outputs and what are visualizing?
I was I was trying to ask if it's something you want to talk about.
Yeah, we can. But the thing about output and visualization, we're going to get there. I want to what I want to do is I want to run down from the basics and then okay, so this is the thing. I looked at the 2D kinematics code, right? I don't want to explain programming using the 2D kinematics code, because if I do that, it defeats the purpose of the task. So what I want to do is I want to explain the basics with unrelating ideas. like age, name, how to calculate tipping, and other things. And then when we're done with that, we come back and look at the code. So we're going to do output and visualization. We can just do like a sine wave, something like that. I think that's still output and visualization, but we need to still understand all these data types and all this, so that like when you get there, it doesn't look so bizarre. You understand? So the idea is, if the service is good, um let's give them 15%, 15% tip. So like if you bought food of 100 naira, you are going to give them 15 naira. Or if you bought food of 10,000 naira, you give them tip of how much? 1,500. So uh if the service is meh, I mean, not good, not bad, let's give them 10% tip. Okay, so let's just write a quick program to do that. The first thing we need to know is how much was the food to start with, right? So that's the bill. So we can say bill is equal to, again, you can see suggestion is already there. And again, suggestions have become very, very good. And this is I just want to point this out because it can read my comments and predict what I want, right? Not all suggestions are correct, but it makes you move extremely fast, like super fast. But again, you should be careful when you press tab to complete each. And then you can see it has given you the pseudo code already. If the service is equal to good, it's a bit addictive because you move twice as fast. Here I've told you, if the service, because now we've looked at the bill, we've looked at the service, was it good? Was it good or was it meh? You pick one. Now, if the service is good, then we give them the bill, which was the amount we put initially, multiplied by 0.15 because we said 15%. If the service was meh, then we give them 0.1%. Did you have to install anything for the suggestion? Yeah, see, I did. I think at this point, I don't know which was it, right? I don't know which was it actually, but I installed a shitload of things over time. So there's Pylons, there is Python extension for from Microsoft. They're all from Microsoft. No, just Python extension. And then there's Python debugger. I'm guessing it's the Python extension and VS Code, AI, blah, blah, blah. But just wake up and you see things all by Microsoft. All by Microsoft. Okay. So else our tip is 0. Python is just basic English. So good. We run this now, and at this point we are being asked, hey, what's our total bill? And then I'm like, okay, my bill is $100. And he said, was the service good or was it meh? And I see my service was good. And they tell me, oh, okay, my tip is 15. Because I said whenever it's good, it's 0.15. But this is actually a bad code. But I'm just using it as an example for you. It's a bad code because what exactly is meh? And if I don't spell meh exactly how I said it, like, and then I'm like, oh, okay, meh. I mean, this also counts as meh, but it's going to suggest 0 tip because I did not get exactly. I mean, the meh I suggested is like with 2H, and then this is like 3H. It needs exactly 3H. So it's a bad code, but it explains what I'm trying to say. A win is a win. So a better way to do it is, yeah, I should give tax. Ah God, if tax just hungry me to give. A better way to do it is what am I doing? What am I doing? What am I doing? What am I doing? On my timeline. Okay. Good. So a better way to do it is tax one. Um, I mean, this is tax three. Yeah, tax three. But this is not really necessary because it's not really robotics. Well, we have a practice. Implement this bill, but with star ratings. So it's going to be like 1 star, 2 star, 3 star. Tracy, please don't cry. Improve it, but with star rating. So like maybe if it's like 1 star, 2 star, you feel free. 1 star, maybe 0.1% or like 1%. If it's 5 star, you can give them 50%. But I don't know why you want to tip them 50%. Just buy another meal. So that is on flow, right? So the next thing we'll talk about on flow is loops. So I can rename this as flow if, just to make sure we are not confusing each other. And I name this as flow loops. The different type of loops. While for do while, basically that's like the basic one. Every programming language have these 3 types of loops, and they all have the way they work. Some work by incrementing first and then looping. Some loop and then increment. They're all technical things. Some have different big O notations. Big O notations is like it's something that computer science do a lot to like optimize how long a program works. I've not really had time to study all those notations, but it helps if you're optimizing. So let's introduce another data type, a list. We've never talked about lists. We've talked about strings, integers, floats, boolean, double. Yeah, but we haven't talked about list. List is like, hey, some things are better when they are like in chunks. So we want to find the average of a number. Sorry, the average of like a sample or a population set of numbers. They're like 1, 2, 3, 4, 5, 6, 7. I think it's going to be dumb if you write first number equals to 1, and then you do second number equal to 2, third number equal to 5, and like that. And then you now do your average to be first number plus second number plus third number plus fourth number divided by 5. It's going to work. I'm not going to lie to you. It's going to work. It's going to compute the average, but that is extremely slow to program. Right? It's extremely slow to program, and my best guess is that might take up more memory. That might take up more memory, but it's definitely the slowest way to code it. So we can put it this way: numbers that we want to code is equal to okay, and see we have that, and we have 1, 2, 3, 4, 5. There are different things we can do with numbers actually. Now you can see numbers. We've created a data type which is list, and there are a couple of things we can do. We can do numbers dot append. This is like we want to add another number to it, and then if we print this is going to give us, where am I printing that error? Hold on. I don't think I'm in my terminal anymore. Oh, okay. I think there's something you guys should also like find out how to use all these things up there. They're like a lot of things up there that you can use, but I'll still cover it when we are doing ROS actually, because as you can see this ROS thing that is here. It didn't just get up there. I configured it up there. So We can do that all later. And then which of the terminals do you use? I'll explain all those later. Okay, so run. I'm getting an error, which is the thing I usually don't use the run button on a normal day. I just do Python. I just do like this on a normal day. Because why? When you're doing C++, I'm lazy to set up VS Code. Till today I don't run C++ with this button, because I'm just lazy to set it up, because I can easily just run I can easily just compile it on terminal on command line. So I just compile on command line. Does it take more time? I mean, considering I have to type it out, yes, compared to clicking off the button. But is it convenient for me? Yes, it's convenient for me. Also, I tend to work more on headless machines where you don't really have anything to see. So you need to know. Also, the buttons you click runs all those things in the terminal by itself. The buttons you click run it in terminal. But I don't know why this is I don't know why this is. Oh, I know why. I know why. I actually know why. Delete that. I think I know why. Yeah, that's why. I found out why. But I'm not. I don't think I have the strength to explain that, because that's besides the point. Okay, so okay, good. What I wanted to do was to find the average. So what's the code for average? The code for average is you add up all the numbers and then you divide it by um the number of the numbers. If that makes sense. So what we are going to do is we can now create a for loop. First of all, we create a total that is equal to 0. And then you might ask, why are we creating a total? What we want to do is, at the end of the day, we need total divided by frequency, total divided by the number of the numbers. So we need a variable to hold the total. So what we'll do is total will first be 0, and then we take the first number and then we put it in total, and then we'll go to the second number and then we add it to the total. We go to the third number, we add it to the total. So that's why the thing is, you have to find a way to that the computer will understand it, and this is like the go-to. So for number in numbers, I think that's the suggestion that they are giving us already. Total, what this means is, you can see, you just put something like this. It's going to work, but there's a reason why it's working. Total is equal to total plus number. That's what that means. Number. And why is this important? For loop is going to run for number in numbers. What that means is, for every number, 1, 2, 3, 4, 5, it's a number, and then this whole thing is called numbers. So for every number in numbers, take the total, which is 0, first of all, add the number, and then continue running the loop. Let me show you something. Let me print, let me show you so you understand. I will print the number so that you know which number we are on. I will print the total, right? Let me call it old total, so you keep track of total so far. So I have current number. I'll call this current number, then the total so far, and then this is my total that it's printing. Okay, and I'll print final. No, I'll print new total. Print new total, and then I print my final total. I don't know if I'm going too fast. I'm aware I'm going too fast, but the thing is, you are going to look at the recording and you will probably watch it. Yeah, what's up? I can see your hands.
Hi, can I ask something? I was trying to raise my hand, but it's not effective.
I can hear you.
Can
So
you
what's
get
up?
me?
I can hear you.
Hello? Ah,
I can hear you. I can hear you.
oh, okay. Okay, so like I wanted to ask, instead of us confusing ourselves with a lot of variable names and keyword that's inside this Python, why don't you check my
Why
phone?
don't you?
Sorry, I'm outside and I'm using my phone. So like, why
Yes.
don't we name that our total plus every of the number, which is 0 plus 1, 0 plus 2. Why don't we name it something else instead of naming it total again? Maybe we can
How
name it
many?
final total so that we're not confusing ourselves.
Are you talking of renaming the variables, like creating the variables?
Yeah, yeah, yeah. Renaming that
How many?
the final total, right? Renaming this final total that the answer will be 0 plus 1, 0 plus 0 plus all the numbers in the
I mean, how
array
many?
there.
How many
Like
variables?
renaming
How
that
many
total
variables
to
do you think
just
you end up with at the end of the day?
sorry.
How many variables do you think you end up with at the end of the day?
I don't, yeah, I'm here.
Major, I'm with you.
I don't.
If for every total
We end
you
up
run,
we end up with the with that final filter. Yeah.
no, no,
Yeah.
no, like what if I understand what you're saying is instead of this variable name, like this actual variable name total, right? We should create new variable name each time we run so that we can keep track. Is that what you're trying to say?
No, I'm saying that this total equals to total plus number. Why don't we name that total there as final total equals to total plus number
I mean,
so that when we are printing
that's doable.
printing new total will now be print new total da, da, da,
Yes, I
and
understand what
then
you're saying. Yes, but
final total.
that's like that again. That's like the waste of.
Because
That's it's the
imagine.
waste of one variable.
Okay,
You don't actually need that variable. Again,
okay,
I
because
know, I know.
I was asking because, for instance, we have a lot of code, and then maybe another developer is trying to read your codes, and then
Yeah,
let them know
yeah,
not go
yeah.
and get
I understand what
confused
you're
that
saying.
what total is
I
this,
understand
this.
what you're saying.
Yeah.
But what I want to explain to you is in programming, right? There are things that are reasonable in some cases and they are not reasonable in some other cases. Say for example, let's look at just this. This looks okay, right? Like using F here looks okay because we want to do final total and want to paste this. But if I do this, if I do print and I do F and I put this and I go with my total, this also works, right? It's literally the same thing as this, but this is just not clean code because it's not relevant. You could have just done print total instead of having to put F and all these things. So think of it as this F and all these symbols you're putting is the additional variable you want to create. There are cases where it makes sense to create an additional variable for readability, and there are cases where it doesn't really, you don't really need an additional variable. So again, it's your code. You know how to run codes, so you can always put new total. But mind you, if you put new total and you want to add things up, you would know that, okay, yeah, you've created a new total and you'll be printing out your new total clearly. But the question now is like, this total now becomes what is called an intermediary. Like, it's like in it's not really useful now. It's just you're just using it to like add things up. But this loop will not even run to start with, because see, look, you would have to try this. You would have to like try this out on by yourself, because your total is starting at 0. Here would be 0. The next loop that is running, your total is still 0. So it cannot really increment the totals. You know what? You would have to like try it out to find out. Even me, the first time I came across loops and all these things, so it's difficult to like visualize in my head what's going on. You'd like try it out and see how the loops are playing. And but just know that that's that idea that you are like thinking of, it's not going to run. So this is for lists. I'm trying to like move a bit faster so we can get to like the other sides. So we have functions. From what we've talked about so far, we've seen you can keep on you can just write your code to follow one line, and then when it's done, it just ends. But you can break your code into functions, so like it's easier for you to call it again, right? So for example, we want to convert from Celsius to Fahrenheit. So we can say Fahrenheit is equal to Celsius multiplied by, this is the formula. For some reasons, we have it. Right? So we can now say our Celsius will be equal to 100, for example, and then print Fahrenheit. Very, very simple code, straightforward. Yeah, straightforward code. And you can run it. It runs, gives us our answer. Good. But let's say we want to make the code modular, right? We have so many things we are converting. We also have in the code a place in the code where we are converting from Fahrenheit to Celsius, the other way around. And then we have this. We might want to like put things into blocks to like organize. So okay, this is what this is doing, and then we can, instead of having to define the formula again, we just call the function. So that's when we now do something like def. That's to define the function. Now, so what this do is like we create a function that says Celsius to Fahrenheit. This is the formula that we saw earlier on, and then it returns that formula. Like anything you put here would have to be calculated here and returned back to us. So if you have 100 degrees and you put in 100 degrees here, C to F, it takes that 100 degrees and replaces it here and returns everything back to F. Again, you would have to practice it for it to like completely stick, because I'm just like saying it and it's just flowing out because like I know that's what it's going to do. So if you actually run it, it does the same thing. 2 1 2 2 1 2. But the good thing with this is we can even go on to say F equal to C to F of another value, and then we print it. We can continue to do this on and on without having to redefine the function. We can put this as 110, we can put this as 0, and then we can put that 0. I think 0 gives an error. I don't know. 0. Mathematically, should 0 give an error? No. So 0. And we can put this at 2. And then if we run this, we get all the conversions without having to redefine this formula again. So that's like at those points that we get to use functions instead. So let's look at one of the examples that Victory was talking about. What's that? Assigning variables as vectors using numpy. Okay, let's do numpy then. Let's do numpy. But before that, I was about to show you the visualization that you asked of to start with. So let's do the visualization. First, where the types are. So I will do let's visualize sine waves. Sine visualize.py. So in this case, we would have to import. Yeah, so this is the first time we're going to have to import something. This first time we're going to have to import something. Import matlab. So this particular module has classes in it, and like we can import it as PLT. This is like the default thing to do, and you would actually see why. I'll show you why it's the default thing to do. Let's go to documentation. Okay. I might need numpy. I might need numpy. Okay, great. It actually gives the full pseudocode because we named the file as sine. So this is actually like the pseudocode. But let me explain what is happening in the first place. So first of all, we are saying x is equal to, now if you want to plot a sine graph, you need to know what your y is, you need to know what your x is. Your y is sine x, but your x is a range from 0 to 360 degrees, right? I mean, normal math that we all know. So for us to specify from 0 to 360 degrees, we can use this function called np line space. So what this will do, it's going to take from 0 to 2np pi. 2np pi means 2 pi. Np is like, okay, np dot pi is the pi in numpy. Pi is 1. What's pi? pi is like 20/7. Yes, we know, but pi in radian is 180. So 2 pi is actually 260. If you know computers and in maths, we don't really calculate pi in degrees. If you check the 2D links, we specify them in degree because it's easy for us to know that, okay, this is 30 degree, this is 10 degree. But in the calculation, they had to be converted to radian. So here we're calculating, and we're calculating straight up radian. So we are moving from 0 to 2 pi, which is 360, and we're incrementing it by no, this is not increment. We're telling how many slices we should get, like how many, divide it into 100 parts. So basically we're doing 0 to 360. If we divide it into 100 parts, each line would be 3.6 degrees. So what we are going to do is, our y is np sine x, meaning for our y, we're going to have sine 0, sine 3.6, sine 7.2, sine 100 and 100 and what? Whatever that adds up to. But like, we're going to keep on having those sines until we have 100 sines that goes from sine 0 to sine 360. That's basically what this stuff do. So you could as well use this without really having to know what happens underneath the hood, or I mean, it's just easier that way. Now let me show you. I said I'll explain why we import as PLT. I can go on to say, if I want to plot, the code to plot is PLT dot plot, right? This just gives us the raw plots. Forget title and everything. This gives us the raw plots. If I didn't import this as PLT, if I said, okay, let me just import this, then I would have to, you can see now we have this plot with gives an error. I would have to now do matplotlib.py plots. I don't know if you understand. If we do this import as, we can import it as anything. I can import it as goat, and then I would have to change this place to goat, and then everything would have to be goat. Sorry, goat.plot, goat.plot, because we've used goat. So the standard in the, yeah, it's funny, yeah. So the standard is PLT. So when you see PLT, don't think you can't change it. You can change it, but it's just easier for everybody. Everybody just woke up one day and said, hey, let's use PLT. I don't know if that's correct. Probably it's in their documentation that you should use PLT, but it doesn't make sense. You can't force it on anybody. Anything would work. You get? So I can now run this, and please tell me this worked. I don't have strength to debug anything. I can't even see it. Okay. Oh, I forgot. So again, this is something you should know. Like, if you didn't know what I'm about to tell you, you would just spend so much time trying to debug it. When you plot it, for some reasons, matplotlib allows you to plot. Like, it has actually plotted it. But I told you the GUI is different from like the terminal, what happens behind the scene. So somewhere on our RAM, we have these plots. Like, the plot actually exists, but we can choose to show it or not. So in order to show it, we now do plots dot show. It's like, I didn't put the plot dot show, right? Yeah, I didn't put the plot dot show. So the thing is, if you are like glued on the old AI kind of thing, you might run into this kind of issue, and I know, oh yeah, it's just plot dot show, but it's not there, and then you are probably panicking or something. So that's why I always emphasize, learn this stuff basically, and then we get the plots. But slight issue, No, you can't see it because I am. There's a slight issue. Why can't I project my? Why can't I project my matplotlib? Hold on. I mean I can see it, but I okay. Okay. Start with it. Okay, so just for the sake of transparency, let me show you something. If I remove this plot and I run it, we don't see anything. Now you said you can see, I can't see where it is running. Like it's actually running. It's you can't see your RAM physically. No, you can actually see your RAM. We can visualize the stack and the heap and everything on the RAM. You can find out how to do that, but you can't see it like running. And then if I add the show and I run again, they tell me figure one is ready. If I click on it, I see my figure one. And if you get, so we have this, we have that. Yeah. So basically this is what I used for the 2D kinematic link. Because if we come to the 2D kinematic link, let me come here. Let me just copy one thing for reference. Then let's attack it from there. If we come here, you would see that this is the 2D kinematic link code, right? Everything I thought was what I used for the code, nothing special. I imported things that I needed, right? And again, I always keep saying this because when you're trying to import something, you don't just know what you need like that, right? So when I was writing this, I knew I needed NumPy, I knew I needed matplots, but I didn't know I would need a slider, right? So I only imported these two first, and I worked with it for a while, and I saw that okay, I need a slider to like do this stuff. Did I know there was a slider? No, I didn't know there was a slider. I just googled slider and then to build the code, just there's just this fun in doing it. So you can see I talked about a definition. I use definitions about the function, so I can always recall the function. And then if you can see MP cos theta, MP sin theta, we talked about sine, cos, and all of that. And then here you can see where I actually use it as a standalone. And now you know what it actually do at the end of the day. It just solves sine and cos, but in a very creative way. So I would let me go to the part that actually plots. This is the part that plots. Here we see the plots, PLT, figure. In this case, we are specifying that I need 7 by 7. By the time you actually, I said I was not going to do this. Okay, I'm not doing that. But just know that, okay, yeah, all the things that I'm talking about, it's in the code. And every single thing, just like that. So I know this thing looks very intimidating. You see this whole line looks very intimidating. This whole line looks intimidating as a whole. And how about exporting the data of the results to a CSV? Yeah, you can't, but you would have to import. There's a CSV for that. It's only. I think I did something like that this morning. Oh yeah, but I can't show that code. It's can I show the code? I'm coming. No, I can't. Okay, so I did that. I think there's a function for it. I think it's CSV. Is it CSV? Yeah, CSV. You can import CSV. Then you know how to use it. CSV dot write. Okay, use the writer, and then you open a CFZ, and then you write the rules into it. It's something you can like just play around with and find out. But it's going to work. Is it going to work? I mean, this line of code looks like it's going to work in my head, but you never know. That's why you debug your code, you run the code. So I'm running. I'm running the code now. I want to see if it works. So just basic stuff. I close it. So we have it there. It works, but it creates the CSV, but it doesn't create it in a. It doesn't do what we expect, but it creates the CSV. I'll show you what it looks like. It literally creates a CSV that says theta 1 and theta 2. So in this is basically how I write code. You make the first mistake and then like, oh, how do I solve this? And this is the problem. The problem is we are using theta 1 and theta 2 not as variables. We're not using it as variables. We are we'll probably have to pass it somewhere where we can recognize it. Here we cannot recognize theta 1 and theta 2 because it is defined. Theta 1 and theta 2 is defined here inside this function. So probably we can write it in this function. We can write it here. Maybe move it from here. We can move it from here, and we can put it here. So we know that okay, yeah, we write it each time we call the function, right? But that begs that raises another question. After writing it, if we call the function and it writes and it opens, how do we handle like constant writing? Are we creating new rules each time we're writing, or we are rewriting on the initial rule? Do I know? No. Will I find out? Yes. So I didn't even know there was like this CSV stuff on Python like right now. I just thought, oh, there should be CSV, and voila, there was CSV. Python is not really my go-to language and all that. So let's assume we've done all of this, and then we close. We get a new CSV. We get a new CSV. Yeah, we get the CSV. And we get the CSV with angles in radians, which is pretty cool because now we find out that the CSV is not writing new lines. If I should open this, let me close this first. And let me open save changes. No, I don't save changes. So if I should open it now, you see it's cooler now. You can see it's actually writing the stuff, but it's writing it in radians. It should be cool if like if we are seeing it in degrees. So what will I do? I will think of how to make it in degrees. Now I wrote this code, and this is the stuff. This is where we converted. Theta. I can do this. What can I do? I can do rad to degree, right? I can do np.rad to degree. Yeah, I can do this. I mean, what stops me from doing it? And then I run this instead. And come up. Right, we have it up running now. So I'll just like play the beats up around, move this around to, and I close it. And let's see. We have one in degrees, 75 degrees. Now we can see something that looks like degrees, and probably this is 0.6 degrees, maybe not, but either ways we can see that we have some things that are in degrees. We'll never get 75 if we're using radian, so it works. Another thing we can consider is how do we now write it in a new line, right? How do we write it in a new line? For that, I've never used the CSV library, so I'll most likely head over to CSV and like, okay, CSV library, or you can, if you're like, you can go to ChatGPT too. Either ways, provided you understand what is there. You tell ChatGPT, hey, I'm using the CSV library. How do I write the code into a new line? And it's just going to do it for you. The only problem is, do you realize that if Do you realize that if every single thing I have been doing was ChatGPT, then debugging debugging your installation problem would have been a mess. Because there's something that happened a lot of time that I did the whole debugging thing with. They'll be like, oh, you can use ChatGPT. And I'm like, okay, fine, no problem, use ChatGPT. And it's because I always say this warning. I don't want you guys to like build technical debts. Like, you think you're good at something, but you're not really good at it. Right? So you think you know it because ChatGPT is like doing it for you. But like when you have interviews and then you're in front of these guys and they ask you things, you find out that, oh yeah, you don't really know it, you just know how to use tools, that kind of thing. So this is basically how I write. You've seen how I write code on the go. We just do things, we just walk around. And I've not even started reading the library. So if you start reading the library, you feel a bit more powerful. That being said, where was I? Okay, I was at the sign thing. Okay, so I want to show you something pretty cool. If I take this to 200, you won't really notice the difference. But if I take this to 200, you see the sign graph still remains sign graph, right? It's still signing. But what happens if I start to drop it? If I drop it to, it was 100 before. If I say 50, right? We look at it, the sign graph is still signing. It looks pretty nice. But you're going to do something. I drop it to 20, and then you would find out something. I don't know if you can see it. Maybe your network might not be so clear, but like we are beginning to lose the curves. If I make it 10, now you can see we're beginning to have more like lines, right? We need to have lines. So and then say I make it 5. Or 5 will look so disgusting. Even the AI is suggesting I should do 15. Now 5 I want right, leave them for me. So there you see. I mean, so this is what is called resolution, right? Where I'm 5.1, 2, and then 3, 4, 5, 5 points, right? So it's just how computers, yeah, small size, higher accuracy, yeah, like that, just like time steps and yeah, common knowledge. But that's how you play with it. So there sometimes again, if you use smaller size, you have more numbers and you have more computation to do, right? You have far more computation to do. So there are times you have a lot of computation to do and might think of like balancing it. So each time we work on embedded systems, we are really like obsessed about this thing. It's called resolution. So we need to know what resolution is what and things like that. So the class is already like 2 hours already. Is it up to 2 hours? I guess. But what have we covered? We've covered imports, right? We know what it means when we say import this as this, import numpy as np. Anywhere we have np is numpy that is there. Now there's from this, import this. Hey, let me show you guys something. There was one very crazy day. There was one very crazy day at work where we were like, all these modules, all these things actually code on their own. Like there's somebody, there's who asked that question? It was Latifa that asked that question. Latifa asked the question that was like, I mean, she asked about this whole import thing, the difference between the code, the import, the difference between all those things. That was like the first class where we looked at code. And I said, you can write this our code for kinematics. You can write it and you can publish it as your own library, right? And then people can import it. So basically all these import, MP, import, these are all codes. Matter of fact, NumPy is just like a library that does matrix for us. So there's a time we were having issue in at the lab, right? And if there's one thing my 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 research lab knows me for, is once something have an issue, they just dump it, like they just leave it, and like they just leave it for me, and they just go. They just have that confidence that I'm going to have restless nights over it, right? So we're having issues with with one piece of code. Right? The code was nice. It was okay. It wasn't that long. It was just like 500 lines. Everything was okay. We used like proper debugging. We did set different points, and like it made sense, but it wasn't just running. It wasn't just running. And I think after spending 10 hours at the lab, because I came to the lab very early that day. I couldn't sleep. I was restless. So after spending 10 hours at the lab, I realized that I just thought of it that probably, just maybe, the problem is not in this block of code that we are seeing. Probably the problem is not in this block of code that we are seeing. Each time you import, especially in C++, what it do is it takes it goes to the file, the numpy file, and it copies all the code in numpy and puts it on top your code. So that's why if you don't need a library, don't add it. So here we have 4 imports. If you look at the code before it is being converted to machine language, this your 61 lines of code can turn into like 5,000 depending on how many imports you have. So, and I said, okay, probably it's not even our code that is the problem. Let me go into what the problem is. And that library was DroneKit. If any of you have ever heard of DroneKit, import DroneKit. I don't know if I have it set up here. DroneKit. That was DroneKit's library that we're using. And I went into the library. If you just press and click on it, this is NumPy. This is NumPy's code. So technically, all these codes get copied into your own code. So I went into the library. This was for DroneKit, and I had to like make changes. Now, if you make changes on this copy, it doesn't affect every other people's copy. Anybody that does the DroneKit or the NumPy would have their own copy, right? This is just your own, so you can play around, you can spoil it. If you spoil it and you cannot fix it, all you need to do is install a new one, right? So that was the thing. So I still have that code and the fix it was very, very funny because uh I found that out and I gave the fix. Nobody should touch it. You know, that kind of thing that it works, so nobody should touch it. Aha, this is it. Yeah, nobody should touch it. Nobody should touch it. Code. So this is just part of the code that I am allowed to share because this one okay. So this was in Python, and then this was the drone kit. This particular drone kit, I had to like modify it. So I was like, patch mode availability check, like, and then patch class level, da da da. And then I was like, my beg, don't touch, because after how many years, after many months of suffering, it wasn't months, it was a couple of weeks, but it was in those last 10 hours that I found out how to solve it. Like, don't touch. So the thing is, from time to time, you'd have to understand how things work under the hood. This is an actual robotic stuff, so it's not always straightforward coding. And believe me, you go use ChatGPT because ChatGPT is not going to go to drone kits and read drone kits code. Because that day God went to read drone kits code and it's a shitload of lines. Technology, no one, they talk technology. Very long. Now that I think of it, I have a video of this day. I made a video of this day because I always have my phone recording when I'm at work. And God, after that, I nearly asked them to promote me to professor. they just sack me from the lab. All right, so yeah, be careful what you import. What else? So this is every other thing you can do. You can just head over to YouTube and their free courses, or Udemy if you want to spend one or two and all that. So we've covered everything. All these axes, you learn it in plots in Matplotlib and updates. Okay, this is like, I'm not going to explain this, but this is like, I feel good explain, but you can explain that by yourself. Somebody said cloned repo. What are we cloning? I think I know what you're trying to say. Like your own copy of the library, right? It's like a cloned repo, so you can do anything you want to do on your side. Oh, but you good, though. You good. That's a very nice ideology. It's sorry, analogy. That's a nice analogy. It's like a cloned repo. Although you don't really clone it, you just do if you know this, if you know the swing pip install whatever numpy, and that's how you get it. Pip install numpy and tells you so yeah, pip2 is like its own code repository, just like Git, but we are not using Git in this case. So I want to believe that I have somehow made an impact today, even if at some point I was just talking because I know that if else where we're doing the average and the counter, I know that thing was probably confusing if it's the first time you are seeing it. So this is what I'm going to do. I am going to push those changes so you guys see it. Okay, so I'm in my documents. So you guys know this repository, the core repository, and then this is code installation orientation. You guys are familiar with all of this. So today's class was in code, and we can see Python recap and can see all the things we did. But I want to push, and again, God bless the terminal. What I'm going to do is now before you push, I want to sound this warning because I don't want anybody to face this stress. If you know what's going on, you guys all have this repository on your laptop. Good. But maybe Victory had the repository at 2 a.m. and then Taiwo sent me a PR by 3 a.m. and I went to the PR and it was good. And I merged it by 4 a.m. Now you would figure out that the version of the repo that Victory has is outdated because I have merged Taiwo's change. So Victory's local repository is behind my own main repository. I don't know if you get. So if Victory tries to like make changes, it might conflict because he does not have the like up-to-date version, right? And then you hear something like you can google it. It's even on the slide. Rebase. Once your program not enter rebase, you are very, very close to one of the most annoying merge conflicts that you can ever get, because there's a new standard and you want to like write on it again. So as a good practice, what we do is each time we open the repository, we do git pull. So git pull takes like the most current things down to the repository. it fetches it. No, it doesn't fetch. It like pulls it down, right? The problem is it does not give you a chance to compare what you have with what I'll show you. Can I check the status? Yeah, here it shows I'm up to date. Okay, I'm up to date, so the example will not work. Maybe later. But I'll just run git pull instead. And then it tells me I'm up to date, already up to date. Because there was no changes yet. But if there were changes, it's going to like download those extra changes. That's what I'm trying to say. So as you can see, git status, we've not added the new codes. That's code Python recap. We have not added it. So I'm just going to do git add. Again, I can do all this from terminal, or maybe let's just go over this. Git add, git commit, Python recap class, and these are all the things. And then we do git push track origin main, and then just rolls down. Then we're done. Git status, just two-factor authentication. Then we come over to the repository. Repository now. Repository. Yeah, let me see what the repository looks like from an external observer. Okay, I have way too much opened at this point. Okay, so GitHub. Let me just make this bigger. So many requests. Okay. Why is that even possible? Okay. I was GitHub. How do I get to too many requests? Okay. So we have code, and then you can you can see here it says 1 minute ago Python class recap. So you can even click on this and it shows what I did. Just in case you've never tried to do this before, you can see the things I added and all the recaps and everything. So that's how it is. The commit has a name. This is the name for the commit. This is the message for the commit. Yeah, so that's that. All right. I believe we can. Sabrina is doing. Yeah, Victory, what says now?
Thank you. So the question I have is it's not really on what we've been saying, even though there are many other questions, but I can't ask everything in one night. I just thinking, since we started, we've opened things in command prompt, we've opened things in PowerShell, we've opened
Mhm.
things in Bash, and I even opened on Ubuntu last night when you were helping me debug. So, and like all these things are supposed to be towards the same goal, right? But like I want to know like the differences in opening things from these different areas and like when you need to follow a certain path. I also even know
Mhm.
about the whole elevated and running as administrator. So like just
Okay.
all those things, yeah.
Okay. So I can answer. I can answer briefly. So, uh, let me show you something. But then that depends if you can clearly see my screen. But I'll try either ways. I have this toy, right? It's supposed to be like a robotic arm. I mean, it is a robotic arm actually, but it's like a small one, a miniature, right? Good. And it's supposed to be, or in order to control this arm, to like move it around, we are supposed to run code somewhere, right? I want you to follow up what I'm saying. In order to run code, you need a brain or like a CPU, because you cannot run code without a CPU. The first problem comes in that CPU, something like this. This is an example of one of those CPUs. It's a big bone. One problem that arises when trying to use this is, how do you run the code without seeing? Because you do not have a monitor connected to this computer. This is literally a computer, but you don't have a monitor connected to it. You could get a monitor and connect to it, but you are not always privileged to do that, right? Also, before you have a connector, before you have a monitor running, you need to have the drivers, or like the stack that allows you to see. All this now boils down to how to do things without the monitor. Terminal. Good. Now, terminal is dependent on the environment. For some of you that may have noticed, but rarely would you people notice. Probably, or not, let me not say rarely. Rarely is not the right choice of word. You might not know enough to notice, but during some part of the installation, I was copying huge chunks of code and sending. But later on, I had to send them line by line. That's because Linux terminal, or Bash, as you know it as, can process those huge chunks of codes at once because of how they handle the end of the line. Somebody had end of the line error, and I had to explain that to him separately. LF and then CTLF, but keep that aside. Just know that different terminals have different ways they handle these codes. So when you have the Linux terminal, you have the Windows terminal. Windows has two types: PowerShell, Bash, PowerShell, and command prompt. If you go on command prompt, try this on command prompt. Try and change directory, CD. You know those directory where you have document slash training slash all those things. Windows, the command prompt can only take the slash in one direction. PowerShell can take slash in both directions. These are small changes that are dependent on the operating system that you are using. The same way Android and iPhone have their own differences. What am I trying to say? On this particular board, I might want to run Linux on it. I want to run, if you notice, the code you are using to control that robotic arm, the code is working in Windows. It's also working on Linux. It's simple for everybody. The code controls the robotic arm. It could be Windows, it could be Linux. But I'll most likely use Linux here because Linux is light. I don't need 30 gig to run Windows, to run Linux. So I'm going to use Linux on this. But let's say this same robotic arm, good. I want to be able to hold out my hand, and this arm will intelligently know that I'm trying to shake it. And maybe as I hold out my hand, it's going to like move and then come and meet me. And then I shake it and then it returns back. To do something as simple as that naturally, I will need to like train a large behavioral model. It's like an AI, like LLM, but this for behavior. Because I'm like, I want to bring up my hand and I want to shake. I'm trying to be as practical as possible now. Now, in order to train that large behavioral model, I will need a lot of GPUs, like a whole lot of GPUs. Even my laptop with like the latest GPUs from NVIDIA cannot do it because I will need like so many GPUs. And then that brings me to Microsoft Azure. Microsoft Azure, you must have heard of it. They have a lot of GPUs. And then I can tell them, I want to give you GPU. I want to like pay for some GPUs. They won't bring it to my house. So I will just send my code over to them and run these behavioral models on their GPU. I'll just pay because they have a lot of GPUs. Now, if you're adding 2 and 2 together, you would realize that Microsoft Azure will most likely be running a Microsoft related terminal. Because now we don't we see we don't even have a monitor to connect to their many GPUs. That is how many kilometers away. Those GPUs could be in USA. And now we have to work via the terminal. Now that terminal is not Linux. I've used that terminal. It's not Bash. Then you will now realize that, okay, you need to learn other types of terminals. That terminal is not Bash. I think that terminal is even closer to PowerShell. So the same robot too, but now we want to do different things. But now you see, say we don't do work another part. Sure you get. If I just want to run the code that I can control it. So now different situations will put you in different places. We've not even talked about using an NVIDIA Jetson and then the whole problem that comes with that one. So different cases, you would have to bend, you would have to know different things. Now, when you talk about administrator, admin or not, on your PC, on your laptop, you have different users. You can create different users. You can create user 1, user 2, user 3, maybe your 3 brothers. And then I believe it is going to be, I strongly believe it's going to be a blunder if your third born can delete the files of your second born. Your third brother will delete the files of fight go boss, town go spoil, everybody just travel. So for that reason, administrative rights and privileges exist such that user A will not be able to delete from user B. User B will not be able to delete from user C. You can set that up. But let's assume your father bought the laptop for you guys, and your father now wants to be sure that he can observe everything you are doing and delete anything he wants. I mean, he's your father clearly. And then he is now going to be admin. Now there's going to be one account that has the administrative rights, and he's going to be admin. You've heard of this joke, sudo in Linux. You run sudo. If they tell you you can't do this, put sudo, you'll be able to do it. Sudo gives you that administrative rights. But sudo is not on Windows. What's on Windows is right click, run as admin. If you don't run as admin, you cannot become admin from inside the terminal. But Linux, you can run sudo, be an admin. So those administrative rights. Now, one of the things that some people try to do without admin rights is they tried to create SSH keys. And when they tell me, when you show me, it's like, sorry, not create. They try to start SSH or stop SSH. It's like when they run that and they give me the error, and like, hey, it's saying denied. In my mind, I'll be like, if now you for accept, if you are not admin, you for agree me they stop or start SSH. SSH, all those SSH keys, all those OpenSL, these are things that like determine the security. So not just any user will be given that right. It must be an admin. She gets. So I believe this gives you a rough idea. Yeah. So do we have any other question? It could be related, could be anything actually. So all right, in the absence of any question or any form of contribution, we can call it a day and continue the software in group chat. Alpha.